So good morning, everybody, and thank you for choosing to hear this talk about the Linux ABI. In referring to Linux ABI, people very often quote Linus Torvalds' famous slogan for the kernel, "Don't break user space." So I'm going to explain where that slogan comes from and what it means. And I'm going to discuss the changes and drift in the Linux ABI, which I would say has some large print and some fine print. The Linux ABI, applications binary interface, is different than the applications programming interface, with which you may be more familiar. We'll talk about the difference. If there's anything I want you to get from this talk, it's that the reason the stability of the Linux ABI is important is it means that user space and the kernel can be independently updated. If we did not have a stable ABI in Linux, if the ABI changed all the time, that might mean if there was a CVE, a security problem, like the ones that Ava Black's just been talking about, where the kernel needed an update, it could be that you'd have to completely reinstall the system, and that would not have been good for the adoption and popularity of Linux. So that is the reason that ABI stability and not breaking user space is important. Now, let's talk first about breaking. This large pile of glass shown in the right of the image was my shower door just minutes before the photo was taken. The kernel can also break if you do an upgrade, and that makes people nervous. So sometimes, in particular, commercial projects are hesitant to upgrade the kernel. Things that can commonly go wrong are performance regressions, new bugs, which are worse than the old bugs to which we were already accustomed, or perhaps changes in behavior of the kernel, disappearance of features on which we rely. This third category, changes or disappearance of features, that is how ABI breaks typically manifest themselves. So that's kind of a general overview of the talk. Let's discuss some of the details. Obviously, I'm going to explain a little bit more clearly what an applications binary interface is and distinguish it from the API. Then I'm going to discuss some examples of ABI breaks that have been in the news in recent years. One is the Apocalypse Y2038. That is, I think, a success story for the kernel and user space and their cooperation. The second one is less happy. It's about priority inversion in real-time Linux and problems that robotics is having. I work on robotics, so this problem affects me personally in my work. Those two first topics are basically about the large print of the kernel guarantee. The second two topics are more about the fine print. One is rating and maintaining log monitors and reading the kernel dmesg buffer with various tools. And second one is mounting old file systems. Does the ABI stability guarantee cover metadata for file systems? And finally, the topic very much in the news, recently discussed with respect to ABI stability in the run-up to the kernel summit, is the ABI stability guarantee or not for BPF programs. That is currently a hot topic. And then at the end, I'll discuss a little bit about how projects, any project, not just the kernel, might design a good software interface to avoid ABI breaks and all this heartache and controversy that we're going to discuss. But first, let's talk more about what an ABI is. An ABI is something that any compiled program has, and not just a kernel or not just a C program. The kernel's ABI is obviously affected by the fact that it is a long, large C program. For C programs in general, the function signatures that would appear in the header are part of the API, and as far as how they're expressed in the header, but the layout of the binary programs is the ABI. So that is the difference between the ABI and the API. I think of the API as the programming interface as what you see, whereas the ABI is what you actually get when you try to address the kernel with system calls or user space applications. Besides function signatures, there's the layout of structs and the ordering of items in structs, and also the meaning, range, and ordering of enumerated values, or in fact, any other constants. C has the feature when a program is linked that the linker will choose whatever function is in a library that has a matching name to that specified by the application. In languages like C++ and Rust that support function overloads, you may get a different symbol, a different function from the binary if you change the function signature. So in those languages, dealing with having different versions of the same function but with the same name is a little bit easier than it is in C. I should say at this point that understanding C and C++ or Rust, heaven knows, is not really necessary for the rest of this talk. All compiled languages have these same problems. This view of ABI stability is kind of a very nerdly, geeky one. Equally valid way to look at ABI stability is to think of it as cooperation among different software projects. In the case of the kernel, we need the kernel community to cooperate with the compiler communities and the user space applications to some extent, and also, most importantly for the rest of the talk, the C library that implements the system calls. System calls, you may recall, are, since Linux is a Unix operating system, read, write, open, close that files are addressed with, but there's also things like poll and select and mount and unmount and clock get time that I'm going to talk about in just a minute. And so all these software projects have to cooperate with each other, and it's when people in different software communities don't necessarily agree how to solve a problem that we get some hard feelings. So with that, I can't have this talk without telling you what Linus actually said and showing you his warranty for the kernel, which is presented in one of its more safe-for-work versions here. There are many instances of this rant in various forums over the years that you can find online. Fundamentally, Linus says that not breaking user space is the #1 rule of the kernel community, and everyone should know it. And then he goes on to say that he needs to know if people break the rules so that essentially he can bash them, cast them out from paradise. So if you read this, I should say there are hyperlinks to all the resources I have in the talk, in the slides here, and the slides are linked from the abstract at the Scale website. So this is very serious. There is a footnote down here at the bottom. Terms and conditions may apply to the kernel warranty like any good warranty, and those terms and conditions, exceptions, and fine prints and further pages are the subject to the rest of the talk. So with that, you may still be a little bit puzzled as to exactly what an ABI is. So let's dive into an example that has been in the news, is important, and is easy, I think, to understand. So everyone knows how an odometer works. Everyone understands the concept of an odometer rolling over. This vehicle, if driven 1 more mile, the odometer is going to go from all 9s to all 0s. So this is a situation where, in terms of the odometer, The needed ABI break would be to add another digit. Otherwise, it would look like the car was new. It's just so in the case of the apocalypse, the Y2038 problem, where 32-bit time is about to roll over. If you don't upgrade your software so that you are using 64-bit time, you will be rocketed back to January 1st, 1970, which is the 0 time for Linux. And so everyone agrees that an ABI break is needed. 2038 is a long time from now, so why do we care? And the answer is IoT. You can easily see if you think of these kinds of devices, many of which are now running Linux, many of which may have 32-bit processors, that they may well be installed in 2022 and not be replaced. And then there's the other question of, will their software be upgraded between now and 2038? So the kernel community was very motivated to get a solution out there so that newly installed devices could be running 64-bit time. So in fact, there is some good news in that regard, as reported here by Phoronix. In fact, glibc and the kernel community, so the system call implementation and the kernel that they address, are ready for 64-bit time, and you don't have to have 32-bit time anywhere in your code if you're using Linux. So that seems like great news. We have 16 years left, all is well, except all is not well if you're a Linux distribution that supports 32-bit architectures. And here's the reason why. If you think about it, if you started shipping 64-bit time packages now, and you're CentOS or Fedora or SUSE or Debian, then your 32-bit architecture customers will have to recompile their user space applications to use those new libc libraries. And so a lot of people wouldn't be very happy while they should do it, should fix this problem in 2022. Maybe they will want to fix it in 2037 instead. You can't make people stop procrastinating. So the distributions could offer going forward 32-bit and 64-bit packages for 32-bit architectures, or they could do what Debian apparently has tentatively planned to do, which is make people reinstall and have a 64-bit version, for example, of i386 called i386T. And so Debian's recommended way of dealing with this problem will be to upgrade your system from i386 to 386T, which is going to require reinstallation. So this is really where the rubber meets the road with ABI breaks. This is why the kernel and glibc try to avoid them. But here's an example. If you think of the odometer, there was no way to avoid an ABI break. So while the situation with 64-bit time is a little bit painful, I think people have done a good job of getting ready for it. Now I'm going to talk about another situation where an ABI break is needed and has not happened, and has had, from the point of view of those of us who work in automation and control of real-time systems, in not a happy ending, at least up to this point. So I call this section of the talk Servers 1, Robot 0, because the distros haven't had to have an ABI break, but robotics community has some problems. And so let's dive into that and see why. To explain what's going on, I'm going to give you a 2-minute explanation of real-time Linux. So why do we have real-time Linux? Real-time Linux is about low latency and predictability for control systems. It is not about speed, which is a common misconception. To explain about real-time Linux and the need for it, I'm going to talk about a system, a robotic system, that has 3 threads, a high-priority thread, a medium priority thread, and a low priority thread. So we have here a XY plot of priority on the y-axis and time on the x. And the problems arise when the low priority thread and the high priority thread, which say might be operating a scalpel in a medical robot or a machine tool or a motor, when that high priority thread and the low priority thread need to write this or read the same critical data section, and so they share a lock. And so if the low priority thread takes the lock, then it gets preempted and the high priority thread starts to run. The high priority thread will have to stop and give up the processor when it hits the section where it needs the lock. Well, that doesn't sound so terrible if the low priority thread finished its work and released the lock. However, on a non-real-time system, we have what's called priority inversion, where a medium priority thread can take the processor when the high priority thread needs the lock, and it may run for minutes. It may run for an unbounded period of time. That is the opposite of predictability. And so if the surgical tool is not getting the processor because disk defragmentation is running, this is a bad situation. So that was non-real-time Linux. In real-time Linux, we have a fix for that. It is called priority inheritance. It is the simple idea that when the high priority thread needs the lock and can't proceed, it lends its priority to the low priority thread, which finishes its work, releases the lock, and meanwhile, the medium priority thread just has to wait until these two other threads or processes in user space are finished. So clearly, we need both user space threads and kernel threads to have this priority inheritance behavior. And so the difficulty that I'm going to talk about is described by this bug report, which says that glibc, the GNU C library, which is the most used C library with Linux, does not actually honor priority inheritance in its locking. So that is exactly the problem that causes priority inversion. And what's remarkable about this bug is you can see that it was reported in 2010, and I took this screenshot last month, and this bug is still open 12 years later. So how could this bug be open for 12 years? Why would that possibly happen? And you note it's not marked won't do or closed or invalid or something. It's still marked new. So, of course, the reason that this problem, which people acknowledge, for which there are reproducers that in fact are attached to this bug ticket, if you follow this link, the reason for this unhappy situation is that fixing the problem would require an ABI break. In fact, it would require changing the function signature of a system call. And if I ran the world, then we would have fixed this problem at the same time as Y2038, when we're already making everybody recompile. But alas, that did not happen. And I'm not going to go into the details of what is wrong, but let's just say if you're using, say, lib standard C++, the implementation of locks under the hood can easily have the problem described in this bug report. And so who knows what the solution for this problem is? Let's see, we have an open source library, and it doesn't have a feature we need. What could we possibly do about that? A fork! Indeed, it is so. Yes. So in fact, there is a fork because the situation is considered intolerable. And the fork is called librtpi. It's a fine product that I believe originally came from VMware and IBM. And is now also supported by National Instruments. And librtpi is just a pthread library, just a concurrency library that is the same as the nptl, the pthread library that's inside glibc, except that it solves this problem. So it's very easy for people to adopt this pthread library and use it. Or if you don't want to use glibc plus librtpi, you could just use an entirely different C library. And in fact, the muscle C library already supports priority inheritance honoring locks. So this is a situation where it's a little bit extra trouble for the robotics community to adopt this alternate C library, but with open source, at least, we can solve our own problems. So I'm now at the halfway point of the talk, and I'm going to switch gears a little bit now. I've talked about two problems, why 2038 and priority inheritance honoring locks, that are both classic ABI break problems. In that, we're referring to changes in behavior of system calls. However, so system calls in Linux address the kernel, as I said previously, through sysfs and procfs. However, Linux exposes all kinds of artifacts to user space which are not sysfs and procfs, and which can be addressed by programs you write yourself, which are not using system calls, possibly beyond open, close, read, write. And so question is, which of these other things that the kernel exposes to user space are part of the stable ABI? Not everyone agrees. This is the fine print on pages 4 and 5 in 8-point font that are in the kernel ABI guarantee. And you won't be surprised to hear that individuals don't necessarily agree about them. And the answer to these questions is not necessarily known in all cases, I would say, or it changes over time in less obvious ways than changes to sysfs and procfs, which everybody knows about. So let's talk about the first example. Let's talk about the dmesg buffer and files in /dev. I want to clarify. I'm going to clarify the principle that applies to the fine print in general. So if you consider ABI breaks as a board game, and an aggrieved user says, "You broke my ABI," it's an open and shut case in general if sysfs or procfs has changed. Then, in general, if it's not one of the parts of sysfs that's not covered by the ABI guarantee that has changed, it is a regression and the patch will be reverted and you win. And that is happening because you are a user. You are a Linux consumer who wants the system to just work. You aren't trying to tune it or configure it. You just want things to function as you anticipate. And so the large print says that if the change is not visible in sysfs or procfs, then in fact it's not part of the stable ABI. And if you're consuming one of the other things in the list, you're probably a developer, and the user space guarantee, as it turns out, covers developers. So that's what the fine print is about. So the first place that I'm going to mention where this comes up, yes?
That's not really true.
Okay, but do you want me to give you the microphone? Let's see.
Is it on? Okay. If you go back a slide,
Please, yes.
and that no, you lose, no, you can win. PowerTop, it was using debugfs, and if a change I made broke it, and it got, Linus and I had a huge argument about it, but yeah, my change got reverted. And the answer was I had to go change PowerTop to not do it the new way. So the yes you win is definitely true. The no you lose, it matters what the tool was.
Well, that is the perfect introduction to what I'm talking about next. So actually, while we've paused here, does anybody else, since we're at the halfway point more or less, have a question they want to ask? Has anyone aggrieved about an acronym I've used that they don't understand, or some other special jargon? No? Bill?
I've had some people
There you go.
I've had some people tout the virtue of symbol versioning in libraries and stuff. Is there anything you would have to say about that?
Sure. I mean, symbol versioning in libraries obviously helps, but it's not true that you can update the kernel and user space independently in that case, right? You might need to change the user space too. So the goal of the kernel as a project really is to make them completely independent. So, I mean, you get new version of Linux libcdev very often when you install the kernel. But that, that has the headers and so forth in it.
Well, I'm actually speaking as someone who's not a fan of symbol versioning, not a panacea. You hear it from some people a lot.
Yeah. Well, just to revisit this previous slide again for a moment, the other thing you hear is you can just recompile when you get the new headers. But if the meaning of the constants and headers changed, that's not going to help you. If the format of the device file changed, or if it's now 600 and it used to be 644, recompiling is not going to help you. So the really hard ABI problems are the ones I'm going to talk about now, that recompiling is not a solution. The first half of the talk was about the cases where it was a solution. So with that, let's talk about dmesg, which is a utility to read the kernel's own log file that a lot of people use. Dmesg under the hood reads a file called devkmesg. Devkmesg is a real binary file in that it has what look like strings in it, but they're not null terminated. And a lot of people write their own log monitors to read devkmesg, and that's where they may run into ABI problems. So here is an example of a user who's had a problem with the ABI. Here's the addition of the feature that caused an ABI problem. Some developer proposed, why don't we make the conversations in the dmesg threaded? Why don't we order the messages by which thread contributed them? Threading email certainly makes it easier to understand, and it would be easier for log monitors to parse the messages too if they were ordered in this way. The problem is, of course, that it is necessary to add another parameter, which is the thread ID, to the dmesg, devkmesg, in order to support threading. And guess what? Adding another parameter to a comma-separated list in a binary file is an ABI break. And so someone naturally complained. The people who complained were from the GDB community. GDB used to be able to read the dmesg buffer, and something broke in Python when this parameter was added, and so the user was upset. This person was complaining that the problem was occurring in scripts GDB. Now, that is critical for understanding that although GDB is a developer tool, somebody who's using GDB is debugging the kernel and isn't hoping for it to just work because they want to play their game or listen to their music. The scripts GDB is a reference to the kernel's source tree. And so the program that was broken by the ABI change is in tree in the kernel's own parlance. And so this is important because while the kernel community feels free to change the internal APIs on every release and does change them, people aren't crazy, right? I mean, they don't want one script in one part of the kernel's own source to stop working with the rest of the kernel. So somebody who's maintaining an in-tree program, which PowerTop is not in tree. No, because it's Intel specific. Oh, is it? Okay, somebody in the audience points out that PowerTop is cross-platform. Very good. So, so anyhow, the kernel community isn't crazy. Obviously, if GDB is broken and GDB script that is in tree no longer works with dmesg, everyone agrees that this is a problem. So this case, and the problem was fixed and GDB went on working. I mean, obviously, this case shows a little nuance here in the fine print in that even if your problem that you're complaining about is a regression, is not part of normal user activity, if the code that's broken is in the kernel source tree, then people agree that you have a grievance and your problem should be addressed. However, there's yet more nuance here, on probably page 11 now of the kernel warranty. That is in the case of talking about file system metadata, which I am going to turn to next. If there's any kind of stability guarantee that people really care about, in general, they want hardware that they have been using to continue working, but in addition, they would certainly like old backups on disks or USB sticks with important files on them to continue mounting when they are attached to a Linux system. They don't want a kernel upgrade to make it so that file systems no longer mount. And there was, I guess a couple years ago now, a discussion when a developer posted to the Linux kernel mailing list and said, hey, my file system no longer mounts. And I was under the impression that I was covered by the warranty. It certainly seems like mounting file systems is ordinary user behavior, and I am a user, and fix my problem. Or actually, to be honest, he said, here is a fix to my problem, since he was secretly also a developer. However, the maintainer of the file system said, ABI stability guarantee does not cover all the metadata that the kernel happens to accept now. Relying on metadata that is not specifically part of the ABI guarantee can result in undefined behavior, which everyone fears and dreads. And in fact, the problem arose because the developer had written his own file system creation tool. He did something slightly different with the metadata, but the kernel mounted it, and so fundamentally he compressed the super block, so it took up less space for those of you who know that kind of detail. And the maintainer responded that the ABI guarantee covers file systems which are generated using official tools. So this is yet a new wrinkle. I would guess that PowerTop at some level is an official tool. Other official tools might be things like E2FS progs that has utilities like makefs, .ext4 or butterfs utils or zfs utils. But consider these programs are not part of the Linux kernel source tree. They are in separate packages. And the developer, who was not very happy, pointed out that it's a little bit breathtaking to say that maybe fat file systems created by Windows machines are not covered by the ABI guarantee because they're not created by one of these official Linux tools. So there was quite some unhappiness in this Linux kernel mailing list discussion thread. The new picture now of the communities cooperating is the communities making these official anointed Linux tools are cooperating with the libc mount system call maintainers, and when these two entities are working together, then the kernel ABI guarantee is preserved. That's the position that the developer took. So this shows an example where people were even more unhappy than the robotics community, I would say, particularly if their customers had a lot of disks that wouldn't mount. I don't know the details. So we've decided that dmesg, device files, file system metadata are kind of a gray area. PowerTop probably also is in the same category. Let's go on and talk about valid BPF programs. This is a very courant topic. BPF, as a lot of people are probably already aware in this audience, is it's a system call. It's also a virtual machine inside the kernel that will execute programs on behalf of a user. It's a mechanism both to read data out from the running kernel and also to do simple control functions. The original purpose of BPF was to harden the kernel against denial of service attacks so that userspace could present to the operating system filters for packets that should be dropped. It's been wildly expanded to have all kinds of purposes for both debugging and control. And the controversy arose because it sure seems like BPF is a developer tool of the kind that wouldn't necessarily be covered by the ABI guarantee. And so, in fact, the kernel documentation basically says that. BPF is a system call, so obviously it has the same system call guarantees that other system calls. It has the same stability guarantees that other system calls have. But because BPF can interact with vast parts of the kernel internals that are no way possibly part of the ABI guarantee, then it's clear that you can have BPF programs that are not covered. And the controversy that arose was in the mailing list leading up to the kernel summit. A developer proposed the idea of essentially having a UDEV rule for a human interface device that would rely on BPF. UDEV rules, a lot of people probably know, are now a part of the systemd project. They are responsible for helping the kernel recognize hot-plugged attached hardware, looking up device drivers and setting configuration from userspace. And human interface devices are mice and keyboards and joysticks and the like. So human interface devices are clearly used by ordinary users, and ordinary users therefore are relying on UDEV rules, although assuredly they are unaware of it, but they would become aware of UDEV rules indirectly if all of a sudden they stopped working and they plugged in their mouse or attached it with Bluetooth and it didn't work. That is exactly the kind of ABI break that Linux would like to avoid. And so the conversation about this topic was very interesting. The developer who wanted to make a UDEV rule that relied on BPF made the point that seems very reasonable that it would be seemed inappropriate to change a device driver in the kernel by submitting a patch if you merely wanted to change the backlight color on the keyboard or the button assignment of the mouse. That's kind of a heavy lift. And so the origin of his desire to make a UDEV rule depend on BPF, since BPF is a great solution to this problem, was clear. But if you think back to the diagrams with the handshakes among the projects, he's creating work for kernel maintainers who now have the responsibility of making sure that they don't change an internal so that BPF stops working, so that the mouse stops functioning. He's creating a lot of work for people. And so the position that was taken on the mailing list harkens back to the problem that GDB had with dev-kmessage, which is basically that people suggested if BPF rules, if BPF invocations that were in udev rules were in tree, in the kernel source tree, then that at least gives people the opportunity to have tests that will break if the kernel internals change so that the udev rule no longer works. So this would be putting BPF scripts for the first time on the same footing as the scripts used by GDB. But it would be a little bit of the change in the way the kernel is handling BPF. Since this controversy was going on during Open Source Summit, Linus himself was asked by Dirk Hoendel about BPF programs and ABI stability, and Linus said basically ABI stability is guaranteed whether BPF is used or not, but of course he's kind of talking about page 1 of the kernel's warranty and not all the messy details. So stay tuned as we move together and try to figure this one out and get a happy ending for everybody. So I'm going to cover the last topic here very quickly, which is how to design software to avoid ABI breaks. As with many of the rest of the comments, the solutions here are not particular to the kernel or to C programs, but just good design ideas in general. Or maybe bad design ideas, depending on who you ask. One method the kernel community uses to avoid ABI breaks is we have a couple system calls that are very generic. You can tell, you don't need to know what PR control does to see that a system call that takes all these unsigned long arg1, arg2, arg3 is not really focused for a very specific purpose. This is pretty general. And of course, in C programs, we're free to cast enumerated values to unsigned long, no problem. So if you don't find PR control generic enough, you can use ioctl, which also has unsigned long request and is var args to boot. So you can do a lot of things with these, and if you don't like the existing system calls, at some level you can kind of roll your own with these very generic interfaces. So, but I don't know whether this is a good example of interface design or not. Arguably not. Not everyone is a fan. A second case that is definitely a good ABI design principle is the principle of unused arguments. So system calls that have arguments that no longer have any function don't need to remove the parameter from the function signature. It's perhaps a little bit misleading to have a parameter that has no effect, but it doesn't really hurt anything, and it's better than making people recompile and reinstall, assuredly. Then another interesting recent development, at least to my awareness, is intentionally putting reserved for future use parameters in new system calls. So people are putting in often flags parameters that are essentially bit masks. It has seemed like a lot of security problems have needed new flags for their solution, and people are thinking ahead that that could happen with new system calls. A kind of amusing one is system calls that have multiple versions. So it wasn't an ABI break, but maybe the old version isn't really usable anymore and is kind of sort of deprecated. Clone has clone 1, clone 2, and clone 3. Hopefully with clone 3 we've gotten it right now. And then finally, glibc, the most used C library, has simply not supported some system calls. They're just throwing up their hands, perhaps, or maybe just nobody has stepped forward to write an implementation. Then the most interesting case, I think, is if you read kernel mailing lists, you find that people are discussing ABI stability when they're considering the design of new features. This hyperlink up here at the top is to a discussion where one developer said, clearly the most convenient, logical way to make the new feature accessible to user space is to put it in procfs or sysfs. And the other developer said, we can't do that because we don't know how people are going to use it, and we don't understand what the interface would be. And if we put it in procfs or sysfs, we're committing to maintaining it and maintaining backward compatibility. And so this really shows you the hard decisions that people are making because maybe if it's too hard to use the new feature because it's not in procfs or sysfs, no one will use it. There are no good solutions here. So with that, we're hitting the summary. Just say that the Linux kernel ABI boundary has very clear, well-defined parts and other parts that are a little bit more puzzling, controversial. Some ABI breaks just cannot be avoided, like with the 64-bit time. Everybody agrees about them. With the case of robotics and priority inversion, we didn't have an ABI break, and maybe we should have had one when the 64-bit time came on. The situation for developers and ordinary users with ABI stability is different and perhaps a little bit hard to understand. And if you're writing applications that touch parts of kernel metadata that are not in sysfs or procfs, you should think about these points. With that, I'd like to thank a colleague, Sarah Newman, who will be presenting about live patching in production later on today, and in this very room at 6 p.m., so consider hearing that talk. And then finally, I'll say that my employer is still hiring and has maybe 100 job openings for software engineers. They're all remote all the time, and they're for things like JavaScript and Golang, as well as C, C++. And you can find it at aurora.tech/careers or talk to me. And thanks for your attention. So I'll run around and give anybody the microphone if they are not too stunned to ask a question. I turned it off.
The statement in the earlier part about Linus talking about like not breaking ABI kind of alludes to this, but besides like reviewing of code, is there any mechanisms that the kernel employs to ensure that ABI breakage doesn't occur, like automated?
The kernel does have a lot of more and more tests every year, which is great. Steve is going to respond. Good.
Yeah, believe it or not, there is not a stable ABI. That's not the rule. The rule is not, rule number one is not there's stable ABI. The rule is don't break user space. It's the whole, tree falls in the forest. I say if ABI breaks and no one notices, did it break? No, it didn't. So, in fact, some of the solutions is if you could change all the users before, keep like the old way and the new way and go and change all the users, you could do that too. So you can't really say, is there a test to make sure there's no ABI breakage? It's basically when someone complains. So that's actually so again, people think that, oh, you can't change ABI. Yes, you can. We do it all the time. You just don't break user space.
Right. Yeah, but there are many tests. I'll talk on both microphones.
Well, things that are known for those things that are known to, we know that we test applications.
Yeah, but like this break to GDB was unintentional. That's just the people who approved that didn't think of it. So, oh, you won't be on YouTube if you just speak loudly. You can't speak that loudly.
So I think that one of the questions from what this gentleman said is that if I was to do some work and I want to make sure that I haven't broken things before handing it over so I don't get yelled at for doing stupid stuff, then is there a way for me to do the testing there?
Yeah, you could. You certainly can't think of all user applications. Oh, it wants me to enter my SSH password. Fascinating. And it only popped up now. That is so great. You certainly can contribute tests to the kernel or to glibc. As I pointed out, the problem with priority inheritance and locks was confirmed by the fact that the bug reporter actually posted a reproducer. So that's why that bug, while not fixed, is not closed either. But okay, yeah, could be. Anybody else? Well, thank you all very much for attending.